The Continuous Use of Fossil Fuels by Declan Boyd, Leighton Fincham, Jackson DeCuson, and Sam Ryan. What's the problem? The problem is that the use of fossil fuels is producing detrimental effects to the environment, like air and water pollution during the energy extraction. Air pollution can cause severe health problems to just about anybody exposed, and water pollution makes water almost completely undrinkable. Fossil fuels also cause global warming. According to Frano Barbier, University of Split and mechanical engineer, global warming will increase the frequencies of extreme weather events such as heat waves, droughts, floods, storms, etc. Fossil fuels have the ability to cause so many negative effects on the environment, but we just continue to use them. On the other hand, renewable energy also poses obstacles itself that make an implementation of this kind very difficult. Evan Michelena, Sorbonne University states, meeting targets on renewable energy is expected to have many economic, social, and environmental consequences. As renewable energy sources are considered to form a complex and dynamic socio-economic system, impacts are expected to be significant within local infrastructure as well as social and institutional architecture. This means that even though there are benefits of renewable energy, it may not benefit the environment as much as the people in the world would have expected. Furthermore, fossil fuel combustion in transport and for power generation has significant negative impacts on local air quality and thus on people's health. Concerns about these negative impacts are playing an increasing role in decisions to start phasing out fossil fuel use in both developed countries and emerging economies. Again, fossil fuels are being used so much that they cause harmful health effects on people and worsen breathing and possibilities of being hospitalized for health. Fossil fuels are causing long-term negative effects on the world.
Now here's solution one, which is using natural gas as a bridge fuel. Realistically, we need fossil fuels to bridge to renewable energy. Because of the obstacles relating to the implication of renewable energy, we cannot totally drift away from fossil fuels. Natural gas is one of the more cleaner fossil fuels, so it makes sense to use them. Presenting natural gas has many benefits. Michael A. McKinnon at the University of California suggests that natural gas represents a cleaner and more efficient fuel, and replacement will have emission benefits. National Geographic states that many people consider natural gas as a bridge fuel because it produces less greenhouse gas during the combustion process. Both of these implications show the various environmental benefits that come along with this solution. By using natural gas as a society, we are still able to rely on fossil fuels, which is beneficial because many people cannot afford to make the big change to renewable energy. Furthermore, as shown in the picture, the low cost of natural gas also makes it a reliable bridge fuel. Additionally, Z. Kosfather states, widespread natural gas generation capacity could help support the future adoption of distributed near-zero carbon generation sources, as its fast dispatch potential helps allay grid intermittency issues associated with renewables. The fast dispatch potential of natural gas contributes to helping with problems associated with renewables. Moreover, the domestic availability of natural gas is a main contributor to why the implementation of natural gas is effortless. Worldometer states that we have 52 years left of gas according to our current consumption, which is plenty enough time to convert to renewable energy. One of the major limitations of using natural gas is the high methane emissions. Robert W. Haworth at Cornell sheds light on the fact that natural gas contributes to high methane emissions, which is an extremely potent greenhouse gas. This is because natural gas is mainly composed of methane, as shown in the diagram. Even though emissions from natural gas are less than other fossil fuels such as coal, it is still a fossil fuel and it still emits harmful substances. Additionally, another limitation is that using natural gas as a bridge fuel does not solve the problem, it only pushes it back. Natural gas does not fix the problem with fossil fuels, it only buys time so that we can adjust to renewables. Moreover, even though the supply of natural gas is not going away anytime soon, it will run out. Recently, the U.S. has regulated the use of natural gas, what makes it difficult to implement them on a larger scale. According to PBS, the Biden administration is delaying consideration of new natural gas export terminals in the United States, even as gas shipments to Europe and Asia have soared since Russia's invasion of Ukraine.
So the second solution is carbon capture capture and storage. This picture represents the carbon capture storage process. We can see that natural gas is burned and carbon dioxide is separated from other gases and it is stored. And natural gas is replaced and used again, connecting back to solution one of using natural gases while emissions are still reduced. Carbon capture greatly reduces emissions. According to the CCES, carbon capture can achieve 14% of the global greenhouse gas emission reductions needed by 2050. This also allows for a sustained energy system. If we capture the carbon dioxide, we can still rely on fossil fuels until we reach renewable energy. The IEE Sustainable Development Scenario outlines a major transformation of the global energy system, showing that the world can deliver the three main energy-related sustainable development goals simultaneously. Under this scenario, carbon capture technologies play an important role in providing low-carbon electricity. In 2040, plants with these technologies generate 5% of global power. This helps ease our way into renewable and clean energy sources. The main limitation of carbon capture is that these systems pull time, money, and resources away from the development of renewable energy sources. These systems also don't address other emissions that don't include carbon. The only problem is that there's also a high maintenance to keep these plants running and keep the storage going.
As we look at our two solutions, we see a comparison of longevity, cost, and emissions. Although carbon capture has a much larger longevity, natural gas as a bridge fuel to sustainable energy has much lower cost and definitely lowers emissions. Considering these are both great solutions, we look at a larger scale of emissions to see the problem. An author from the World Wildlife Fund says, the first fact is natural gas combustion does indeed emit less carbon than coal. The IEA's analysis suggests that, on average, coal to gas switching reduces emissions by 50% when producing electricity and 35% when providing heat. But the reality is that even though it emits less, it still emits. And as we look at carbon capture, Lanny Furbank states, no, CCS does not alleviate harmful air pollutants and may actually lead to additional emissions at the point of capture. Because of carbon capture's energy penalty, burning fossil fuels to power the process increases pollutants on site. And as we see in this graph, there's still lots of natural gas reserves in the world, showing that natural gas is the best solution towards sustainable energy.